Okay, this topic is on basic algebra. To put it simply, algebra is the use of letters to represent an unknown number. Okay, so for example, we all know that 2 plus 2 equals to 4. Yeah, but so if I replace one of the 2's with x, I get x plus 2, which literally means adding 2 to a number x. Okay? And of course, x is not the only alphabet we can use. We have also other alphabets like A, B, C, so on and so forth. Okay? Now, since x, A, B, and C are letters used to represent numbers, we can also do our normal operations on them. As we shown here, this is addition, x plus 2. And if I have, let's say, x plus another number, y, then this is unknown number x plus unknown number y. So we can just leave it as x plus y, just like this. We can also do subtraction, x minus 2, okay, and x minus y. Okay? And we can also do addition of the same alphabets. So for example, let's say I have x plus x. Okay? This is going to give us 2x, right? Because there's literally 2 x's now added together. If I have, say, 2x plus x, this is equal to 3x. So in addition, we can only add numbers together in algebra if the letter is the same. And when we add them together, we just take the number behind and make it into one bigger number, which is called the coefficient. Likewise, we can also do subtraction. So for example, if I have 3x minus 2x, okay, since it's x minus x, the letters are the same, so I just look at the number behind. 3x minus 2x is 1x, or just x. Okay, that's for addition and subtraction. Now we can also do multiplication or division. In multiplication, as mentioned just now, we can have, for example, say 2 times a. This gives us 2a. Okay, literally 2 times a. We can also have different algebraic letters multiplying by each other. For example, a times b can be written as just ab. Okay, just how 2a is literally 2 times a, ab is a times b. Okay, and if now let's say I have 2a times 3b, how do I evaluate this? 2a times 3b is the same as 2 times a times 3 times b, and can be rearranged as 2 times 3 times a times b. If we evaluate just this part, we're going to get 6. And we evaluate this part, ab, it's just ab. So 6 times ab can be written as 6ab. In other words, if I have a coefficient and an algebra times another coefficient and an algebra, what I do is I multiply the coefficients together first. 4 times 5 equal to 20. And I multiply this with the 2 algebraic alphabets multiplied together, a times b, okay, which gives us ab. You don't have to write all this. If you can get straight to this step, then that's good enough. And the last thing, what if I have 4a times 3a? The first step is, of course, coefficients multiplied together. 4 times 3 equals to 12. But it's multiplied by a times a. Do we write a times a as AA? We don't actually need to do that. We can write it as a squared. Okay? So in other words, this a squared here, okay, let's just erase the first part. A squared is equal to a times a. And similarly, a times a times a, if we do it 3 times, is equal to a cubed. So the number here on top right, represents how many times I multiplied by itself, by this thing itself. Okay? And of course, not to mention, we have square root. So the opposite of this, square root a squared, will give me back a. If I cube root a cubed, it gives me back a also. Okay? And so what happens next if I square root 4a squared? Well, we know square root 4 is equal to 2, and we know square root a is equal to 8. Root 4a squared can be rewritten as root 4 times root a squared, which is equal to just 2 times a. So when we square root or cube root in algebra, we have to account for both the coefficient and also the algebraic part.